Hello and welcome back to a brand new series, differential equations. And this is when calculus gets hard, let's be honest. But, push through it, get things down, and eventually you'll understand it. And it's really just algebra mixed with calculus. So what is a differential equation? Well, it's basically just an equation with differentials in it. Now, that wasn't a great explanation because it had both of the words in it. But it's really just well, you know what? Let's look at an example because I can't really explain it without saying that it's an equation with differentials. So, a very simple example that we have here is dy over dx equals x cubed. And from our Calc 1, and learning of antiderivatives, we would know that, well, we can just take the integral with respect to x on both sides and we'll get our solution for y, which is what we're generally looking for with differential equations. But I want to show you a different technique that we can use. And this is what brings us the whole idea of separable differential equations. So let's times both sides by dx. So what we're going to get is dy equals x cubed dx because our dx's on top of each other are going to cancel. And another trick that we can do is integrate both sides. Simple. Very cool. Okay, integral of dy is y plus c. But let's call this c1 since we have multiple integrals. X cubed, integral of x cubed. X to the 4 over 4 plus, we'll call this c2. Okay. Well, we want to solve for y, so let's minus c1 from each side. Now we get y equals x4 over 4 plus, we'll call this our general c, where c is c2 minus c1. We don't have to specify that. And that's really all differential equations is. I mean, not really. There's a lot of stuff, very complicated algebra equations, tricks, stuff that we need to keep in mind, but it's really not as complicated as you might think it is. And that's a general idea of what they are. So the last thing we want to do when we're solving differential equations is check our answer. So up in our first equation that we were given, we have a dy dx, and that equals x cubed. So we're going to find dy dx and see if that equals x cubed. So let's take the derivative with respect to x at both sides. We get dy dx. And that's going to equal, well, 4 times x to the 3 over 4 plus derivative of a constant is 0. So let's not worry about that. Well, our 4's cancel. We get x cubed. That means that we got the right answer. Perfect. Let's move on to another example. Okay, well, this one is a little scarier, but it's really not that hard. Dy dx times x equals y. And I know I said in the last example that we would always want to solve for y, so a lot of times you'd probably just be like, well, there's y, got it, don't have to do anything. But we don't want this here. That's just annoying. How can we know how to graph that? Well, we can't. So how are we going to do this? Well, let's separate our dy over dx. So we're going to get x dy equals y dx. Well, I mean, we could integrate that, but it's not really going to do anything for us because, I'll just show you what would happen if we integrated both of these. We'd get xy equals xy Well, we know that. So how are we going to do this? Let's divide both sides by x and y. We're going to get 1 over y dy equals 1 over x dx. Okay, that's an easy integral. Let's integrate both sides like we did in the last example. We've seen this a million times before. Natural log of y equals natural log of x. Don't forget your plus c. Okay, now let's solve for y. Well, we know that e to the power of the natural log of something is just going to be that something. So we've got y. Let's take e to the power of both sides. E to the natural log of x plus c. Well, this actually equals something else. We might say that we've already solved, which is true, but we haven't simplified. Well, we know that this would be, high school math probably. Depending on what high school you went to. You might have did this in junior high. Or middle school, as it's called in a lot of spots. Well, this is actually going to be e to the power of natural log of x times e to the c. But this also equals something. Well, e to the power of the natural log of x is x. And e to the c, like we said in our past example, well, c minus some other c is going to be a brand new c. But also, e to the power of anything that's not a variable is just going to be another c. So we can actually say that y equals c times x, where we get our x from here and we get our c from here. And that is the general solution to this differential equation. Should we check it? Sure, let's check it. Well, we've got a dy dx and we've got a y in our equation. Dy dx is just going to be c. Okay? So we've got cx equals, what's our y? Cx. Boom. Checked. Done. We got it right. Okay, last example. Now I kind of just put this one in here to scare you guys, but I promise you, it's not that scary. Tan of dy dx equals x. I'm going to show you guys how to separate this, but I'm not going to integrate it because I'm not going to drag this video on. Well, our dy dx is trapped inside a tan term there. But we remember also from our algebra class that we can just take the inverse tan, and that's going to give us our dy dx all alone. So our dy over dx is just going to be arctan x. Simple. You know, there we go. This is like anything we've seen before in the past examples. Separate our dx term. Dy equals arctan x dx. Okay, integrate both sides. I'm going to give the example to you guys. I'm not going to give the whole workout, but I'll give you a little hint. You're going to use, if you're doing this by yourself after this video, maybe pause the video here. To perform this integral, you're going to use integration by parts and a simple u substitution. Okay, well, let me give you the answer here. Y equals x arctan of x minus 1/2 natural log of 1 plus x squared plus c. Boom. We could also check this, but I really don't think it's all that necessary. So, good luck trying to solve this yourself. I'm sure it won't take that long. Maybe also check the answer for yourself. But thanks for watching this video. Next video, we'll talk more in depth about these, and then we'll get into some more complicated differential equations. But we'll be getting into the fun stuff. So thanks for watching.